One thing you should know about rational functions is that they have vertical and horizontal asymptotes typically. So, in this particular example, I'm going to show you what an asymptote is. An asymptote for a function is just a line, it could be vertical or horizontal, that for large values of x, or if you get close to a certain value of x, the graph is going to get closer and closer to your asymptote. So let me show you how this works. First off, notice that the denominator cannot equal -5. So the domain for this rational function is all real numbers except -5, because if I put in a -5 there, I'm going to have 0 in the denominator, and I cannot do that. However, what is going to happen if I put in something like -5.0001, so that I'm not at -5, but I'm really, really close. And in that case, you're going to blow up, right? Because you're going to have -5.0001, you're going to add 5, and so your denominator is going to be really close to 0, and you're going to be dividing by an extremely small number. And that's going to cause, when you divide by an extremely small number, you're going to get a very, very large number. So we say that we have an asymptote at x equal -5. It's, first of all, we draw it with a dotted line. So here we are, -1, -2, -3, -4, -5. And it's really a no-go zone for the function, because remember, x cannot equal -5. Okay, so similarly, let's think about what is going to happen for very large values of x. Let's say we head off to infinity or -infinity, either one. Let's say if we take a huge number like 1,000,000 and then plug it in for x, you're going to get 3 million, right? Because 3, and then this -6 is negligible. So is the 5. If you're adding 5 to 1,000,000, it's negligible. So let's just pretend they're not there. You're going to have 3 million divided by 1,000,000, and that's going to be 3. So for really, really large numbers of x, your function is going to get closer and closer to 3, almost, but not touching. It's not going to be equal exactly to 3 because of these numbers here that throw it off, but it's going to get really, really close. So that means that y equals 3 is a horizontal asymptote. All right, so what does this look like? Well, let's figure out where the function is going to be in these quadrants that I've divided up by the vertical and horizontal asymptote. So let's pick like -6. If I plug -6 in here, I'm going to get -18 minus 6, that's going to be -24. And then -6 plus 5 is going to be -1, so it's going to be 24. So I didn't really leave room on my graph for that. I wish I had done that, but it's going to be at -6, you're going to be up here somewhere, and then your function is going to get closer and closer like that. And then if I plug in 0, I get -6 divided by 5, which would be -1.25, so it's going to be over here. If I plug in 0, it's going to be right about there. And so it's going to get closer. It's going to look something like that. That's not a very good picture. Let me pull up Desmos and show you what it really looks like, because my drawing is not very good. But that's how you find asymptotes. And I'll go into more detail that in another video. All right. So, let's see, where am I? Here we are, Desmos. Okay, I've already put the function into Desmos. And here it is, 3x minus 6 in the numerator, x plus 5. I don't think I need those parentheses. I was just using them to, okay. And then I graphed y equals 3 and x equals minus 5. And you can see this is a much better description. If you zoom out, you can kind of see how my graph, this is what my graph looks like. But from, from looking at it, zooming out helps you to see how the asymptotes work. You can see the function in red here gets closer and closer and closer to the line y equals 3, but it never really touches it. And similarly, if you follow the curve, it gets closer and closer in the other direction. It's closer and closer to the vertical asymptote, but it never touches it. So asymptotes are typically not crossed. It is possible for a function to cross a horizontal asymptote. There are some examples of that near the center, but as you get farther and farther away, it's not going to cross, it's just going to get closer and closer. And you can't cross, the function cannot cross a vertical asymptote because that is where the function is undefined. And remember, we talked about the domain. You can't divide by 0, and so you throw out those numbers. And that's where the asymptotes lie, typically, the rational functions.